Okay, ladies and gentlemen, welcome to the video notes for Chapter 4, Section 5 in your geometry textbook. This section is going to cover the other two triangle congruence postulates, angle, side angle, and angle, angle, side, as well as the special case that applies only to right triangles, and some additional proof examples, and the corresponding parts postulate. So, quite a bit to cover. It's probably going to take about 4 videos to do. We covered these notes in one day, but it was a bit of a rush. So I think these video notes will be helpful to you so if you need to go back and review things. So we need to start off with a vocabulary word, included side. An included side is a side which two angles in a triangle share. A side which two angles in a triangle share. I want that to be yellow, so let's get that fixed. There we go. Now, in other words, down here at the bottom you'll see I've got side BC. BC would be the included side for angles B and C. It is a side of angle B and a side of angle C. It is shared by those two. Now, just like included angles, any side could be considered the included side. For instance, AB is the included side for angles A and B. Okay, so whichever two angles we're talking about, the included side would be the side between those two angles as we go around the outside of the triangle. It's the side that those two angles have in common. So depending on which two angles we're talking about, any of the three sides could be considered the included side. Which leads us into our third congruence postulate. We had two in section 4-4, the side-side-side postulate and the side-angle-side postulate. So here we have the angle-side-angle congruence postulate, or ASA. Reads very similar to the others. If two angles and the included side of a triangle are congruent to two angles and the included side of a second triangle, then those two triangles must be congruent. So in other words, the picture is marked up already, but if we have two sets of angles, angle A is congruent to angle D, angle B is congruent to angle E, and we have the included side for those two angles, which would be side AB is congruent to side DE. That is enough for us to state that triangle ABC is congruent to triangle DEF. So again, it's another example of how we don't really need all 6 sets of corresponding parts. We only need certain pieces. We only need 3 if it's the right 3. Okay, so let's do a proof involving angle, side, angle. Again, part of the reason we're doing these proofs is to demonstrate how we use these congruence postulates. The other is to remind us of the other theorems and postulates we've already come across this year and give an example of how they would be used. So this proof is like any other proof. We start with our givens. We have segment QS is bisecting or bisects angle PQR. And we have angle PSQ is congruent to angle RSQ. Those are our givens. Now we haven't used bisector in a long time. But we need to remember what that word means. Bisect means cut into 2 equal pieces. So if QS is bisecting angle PQR, that means it's cutting it into 2 equal or 2 congruent angles. So by the definition of bisector, we should be able to state that the angle on top, which would be angle PQS, or SQP, is congruent to angle RQS, or SQR. Doesn't matter which way you name them, but you have to use the 3-letter method. PQS is the top angle, RQS is the bottom angle. These two angles have to be congruent because QS is bisecting the big angle PQR. So if you notice, that gives us two sets of angles. We have the given pair, which are marked with one arc in the picture in black, and we have the bisector pair, which we just got from the other given. If only there were some way to declare that the included side between those two angles were congruent. Let's have a look. The top triangle, the included side would be QS. It's the side that falls between the two marked angles. For the bottom triangle, the included side would be QS. Anytime that two triangles share a side like that, we've had that a couple times now, we can state that that side, in this case QS, is congruent to itself by using the reflexive property, because they share that side, which gives us a set of congruent sides. That gives us the three required pieces of information to finish the proof. Triangle PQS must be congruent to triangle RQS, because we have now shown angle, side, angle congruence. Okay, moving on. We need to think about rather carefully that the fact that we know two angles in a triangle would instantly mean that we actually know the third. We should remember that from the last section when we had the third angle theorem. So as it turns out, you don't have to have the included side. If you have two angles and any side, including the non-included sides, that is enough information to declare the triangles are congruent. Which leads us into our final congruence postulate, the angle-angle-side congruence postulate, which says if two angles and a non-included side of a triangle are congruent to two angles and a non-included side of a second triangle, then the triangles must be congruent. So in other words, it doesn't matter if we know the included side or the non-included side. As long as we know two of the angles and one side length, that is enough to declare triangle congruence. So again, in symbols, this would have two sets of angles. If angle A is congruent to angle D, angle B is congruent to angle E, and a non-included side, in this case the markings give us BC is congruent to EF, that is enough for us to state that triangle ABC is congruent to triangle DEF, because it doesn't matter whether we have the included or non-included side, as long as we have a side to guarantee that they're the same size of triangle. So, the real difficulty with these two postulates is telling which one we're supposed to use. Because you see, any proof that can be completed with angle, side, angle could also be completed with angle, angle, side. The trick is being able to tell which one will be quicker. Because in mathematics, what we really want is we want the most elegant answer. We want the shortest proof that we can come up with that is still mathematically correct. So, let's look at an angle, angle, side proof. Once again, every proof starts the same way, that is with the givens. So we'd say angle DAC is congruent to angle BEC, and side BC or segment BC is congruent to segment DC. Both of these are already marked in the picture. Now notice that gives us one set of angles and one set of sides in the triangle. But be a little bit cautious with the one set of sides. Notice it is BC from here to the end, and DC. Not the whole length, just that piece are congruent. Okay? So, number 2 says reflexive property. And this proof, really, the whole point of this step is for us to see that it is possible for triangles to actually share angles. They don't have to necessarily share sides. Both of these triangles contain angle C. Triangle ADC, angle C is one of the angles in that triangle, and triangle EBC, where angle C is one of the angles in that triangle as well. So that means that instead of a reflexive side, we actually have a reflexive angle here. Angle C is congruent to itself. Every angle is congruent to itself. Now the difficult part here is noticing that while we have finished this proof, triangle ACD is congruent to triangle ECB based on what we have shown. We have not shown angle side angle, we have shown angle angle side. And to see that, we kind of have to unstack these two triangles. And I know my picture's not perfect here, but that's not what's important. What's important is looking at the markings, okay? If we look at these markings, triangle ADC, we know that CD is congruent to BC in the other shape. So here's B and this is E. We know that angle A and angle E are congruent. And we know that angle C, since it's in both triangles, is congruent to itself. Notice the markings do not include the included side. It's a non-included side. So that would be an angle angle side proof. Okay. That is where we're going to stop the first video. The next video is going to cover hypotenuse leg and the summary, as well as the non-proof major skill. Then the video after that will cover the corresponding parts postulate, the extra proof examples, and then the final video will cover the corresponding parts postulate. Thank you very much for your time.